Six things to know or remember about inverses of functions. And of these six things, they're all related, and we'll see how. The first one we're going to look at is in the upper left. We have inverses of functions are not always functions. And it says use HLT. HLT is an acronym for the horizontal line test. And we look at the little graph on the left. We have a quadratic function, and if we use a horizontal line, we see that once we come up here, this horizontal line shows that we touch twice, hence it fails the horizontal line test. Because the horizontal line test determines if, when we take the inverse of this function, that inverse will be a function. Of course, when we rotate this parabola to open to the right, that rightward opening parabola is going to fail the vertical line test. So inverse functions are not always functions. And here we have kind of a cube root function, and we see that our horizontal line touches only once. So the inverse of this cube root function will be a function. And coincidentally, this next thing we're going to look at, functions that are inverses of each other reflect about the line y equals x. Here we have a dashed diagonal red line, which is the line y equals x, and it is a reflection axis for the function, the cubic function g of x equals x cubed, and the cube root function fx equals the cube root of x. And we can see that this red curve and this blue curve are reflections of each other about the line y equals x, indicative of inverses of functions. In the upper right, we have the domain of a function is the range of its inverse function. Here we have two functions, y equals e to the x, exponential function, and below y equals ln x, which is the natural logarithmic function, and ln x means log base e of x. And we can see that the domain of the exponential function is all real numbers from negative infinity to infinity, which is the same as the range of its inverse, which is the natural log function. Again, all real numbers. And also the domain of the natural logarithm function, greater than 0, less than infinity, is the range of its inverse, the exponential function y equals e to the x, greater than 0, less than infinity. Next, in the lower right, we have the composition of functions that are inverses of each other is the function f of g of x equals x, or g of f of x equals x. And this little circle between the f and the g, and also between the g and the f, is not a letter. It's a little smaller than a zero. It's fainter, and it means composition of functions. And here we have two functions, f of x equals x cubed minus 3, and g of x equals the cube root of quantity x plus 3. And if we insert and make the composition, in this case, putting the g, f of g of x, we put the g function in place of this x and the f, and this is what the algebra looks like. And we see that the cube root and the cube cancel each other out, so we have x plus 3 minus 3, which simplifies to f of g of x equals x. So when you have two functions that are inverses of each other, they are going to, their compositions anyway, simplify to x. Next, for inverses of functions, y's change to x's and x's change to y's, and we have two tables here, and we can see that the x's and y's are switched. And really it makes sense in relation to what we've seen already for the domain and range, and for reflecting about the line y equals x, once you think about it. And the last thing we're going to look at in this anchor chart is a four-step process for finding the inverse of an algebraic function. Step 1 is change f of x to y. So if we have a function in f of x format, in this case f of x equals x cubed plus 4, we can change that to y equals x cubed plus 4. Step 2 is to change the y's to x's and x's to y's, and so we have y equals x cubed plus 4, we change the function to be x equals y cubed plus 4. The third step for some inverse functions is quite a elaborate step. But in this case, we have solving for y. So we have x equals y cubed plus 4. So we solve for y by first subtracting 4 from each side of the equation. And so now on the left side we have x minus 4. On the right side we have y cubed. And when we take the cube root of y cubed on this side, we end up with y equals cube root of quantity x minus 4. And then the fourth step is to change y to inverse function notation, which is this f negative 1 of x. And that negative 1 looks like it's an exponent, but actually it's inverse function notation. So just be careful about that. And so that changes the function y equals the cube root of quantity x minus 4 to f negative 1 of x, or the inverse function of x, equals the cube root of quantity x minus 4. So anyway, these are good things to know about inverse functions that I hope will be helpful to you. Good luck, and thanks for viewing.